VRF stands for Variable Refrigerant Flow, a method of varying the volume of refrigerant circulated in the system in relation to demand. As demand drops, so does the volume of refrigerant circulated by the compressors. The compressor can slow down and pump less refrigerant to meet the current demand of the system. We'll explain the differences between a VRF heat recovery system and a VRF heat pump. One of the big differences between a VRF heat pump and heat recovery system is that with a VRF heat pump system, all the units must be in the same mode, either cooling or heating. As seen here, this one outdoor unit can feed many indoor units, but all the indoor units need to be in the same mode, such as heating as shown here, or all in cooling. With a VRF heat pump system, if each zone or office wanted to control whether to heat or cool their space, then each would require their own outdoor unit. Here we have an executive in office number 1 wanting heating, while the second office wants cooling. Each indoor fan coil will require a separate outdoor unit, and the third office is also calling for cooling and will have their own outdoor unit. To reduce the number of outdoor units, the engineer will group together those zones that have similar load profiles. So, indoor fan coil number 2 and 3 have similar load profiles, so we can get rid of one of the extra outdoor units and its piping and connect fan coil number 3 together onto outdoor unit number 2. This saves on outdoor units. Now, whenever fan coil number 2 and 3 switch modes of operation, they will always be in the same mode as they're on the same outdoor heat pump system, as shown here now in heating mode together, while the outdoor unit number 1 can be any mode separate from the other system. The benefit of using a VRF heat pump system over the traditional split system heat pump is that you have an inverter compressor and multiple indoor fan coils all working together to achieve a lower energy consumption. The disadvantage when we look at the VRF heat pump versus the VRF heat recovery, as shown here, is that if we install a 3-port branch controller box and connect the refrigerant piping to the outdoor unit, we can then connect fan coil number 1 to the branch controller, allowing that office to choose to be in heating or cooling mode, in this case heating. Then, without having to install another outdoor unit, we can add fan coil number 2 to the branch controller, and that office can be in cooling mode. The same for fan coil number 3. We just pipe the fan coil to the branch controller box, and that office can choose any mode of operation, in this case heating. This can all be done using one outdoor unit with a 3-port branch controller, which is one of the advantages of using a heat recovery system as opposed to a VRF heat pump system. The heat recovery system also makes great use of the heat being rejected. The heat rejected from fan coil number 2 can be used to heat the spaces serving fan coil number 1 and number 3. Cost of VRF systems. To determine which system is more expensive, an analysis will have to be done. If we have 2 small identical office buildings as shown here, with the first building using a VRF heat pump system, the heat pump system would require at least 2 outdoor units, one for the south exposure and the other for the north exposure. The heat recovery system is perfect for this type of balanced zoning and will require only 1 outdoor unit, but will need a branch controller box to route heating or cooling to the indoor units. The total amount of piping, fittings, and insulation costs will need to be determined between the 2 designs. All of the outdoor units and the branch controller will need electrical power. All of the indoor fan coils will have their own controller, so there is no difference in cost between the 2 systems here. The VRF heat recovery system will most likely require the greatest initial investment when compared to VRF heat pump or traditional air conditioning systems. The additional cost for the VRF heat recovery system comes from having more components and a higher level of installation and commissioning costs. The initial cost of a VRF system should be analyzed based on life cycle cost, which will be impacted by the energy cost and saving factors. If you are an HVAC contractor or engineer that tracks the cost of VRF systems, then the VRF Wizard has a VRF system cost spreadsheet for keeping track of these types of projects. All air conditioning systems, including VRF systems, are made to move heat from one location to another depending on the mode of operation. Heat is either brought into the building or rejected out of the building. Using a VRF heat pump in cooling mode, heat is absorbed into the refrigerant from the warm indoor air blowing over the coil. The heat is then circulated by the compressor to the outdoor unit where the heat is rejected through the outdoor coil into the outdoor air. For a complete understanding of the refrigeration cycle, see our video on Refrigerant Cycle 101. The heat pump has a reversing valve which changes the direction of flow to each of the two coils. In heating mode, the indoor coil now becomes the outdoor coil. So during the cold winter, the outdoor coil acts as the evaporator and absorbs heat from the cold outdoor air. You're probably wondering how there is any heat in the cold winter air. Well, this is the magic of refrigerants, as R410A is commonly used in VRF systems, and this refrigerant boils at negative 55.3 degrees Fahrenheit, minus 48.5 Celsius. That means this refrigerant circulating in the VRF system can still absorb heat from the cold outdoors and send it to the space to be heated. See our video on how heat pumps work for a better explanation. So it's easy to remember. One coil absorbs heat, takes it in, and the other rejects heat, throws it out, all with the magic of refrigerants. A much better and more efficient use of the heat being removed is to use it for some purpose, such as for a room needing heat while another zone is in cooling mode. This is what a heat recovery system is good at. With a VRF heat recovery system, the branch controller will either send the heat absorbing or heat rejecting refrigerant to any space depending on whether the space wants heating or cooling, based on the demand of the controller. So, if heat is absorbed into the refrigerant from a space needing cooling, it can be rejected by the refrigerant into a space needing heating. This is the basic principle of a VRF heat recovery system. We'll cover these systems in more depth in other videos. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.